subscribe to our channel for latest video series on GATE, UGC, NET and more. Also press the bell icon so that you never miss an update on any latest video. For more information you can visit our website or call on the numbers below. Hello people, so today we are going to look at some basic properties of unit step, unit ramp and unit impulse signal. So these are three basic signals that we are going to use very frequently. So we are just going to look at some properties and how we are going to use them. So we start with unit step signal. Unit step. So what happens is, if there is a signal, you've got a signal that has only steps in it, that is made up of only steps, then we can represent that signal completely using unit step signals, shifted unit step signals, where the shift of the signal represents where there is a change in the step and the coefficient of the signal represents the level of change, okay, amount of change in the step. So we are taking an example to see this point. Suppose you have got a signal like this. Right, so you got a signal like this. Right. So this is what signal we have got right now. Now so as we can see, this signal has got only steps, okay. This is only having steps in it, okay. It is only having step changes. So what we are trying to say is that a signal like this can be represented completely using shifted unit step signals. How? See, okay, before this question I am taking a small example. Suppose I draw ut minus 1. Ut minus 1 is a shifted step signal which is going to begin at t is equal to 1. So this is how this ut minus 1 is going to look like, okay. And again another signal that I am having is ut plus 1. Ut plus 1. So this ut plus 1 is going to begin at t is equal to minus 1. So this is how ut plus 1 is going to look like. Now see, these are two shifted step signals. Now by adding and subtracting these two signals, I can have a variety of signals. Suppose first signal that I make is ut minus 1 plus ut plus 1. Now see, when I am adding two signals, we have already seen this, when you are adding two continuous time signals, it is like a union of the signals. So the signal, this equivalent signal is going to lie between minus 1, it is going to start at minus 1 and continue till infinity. Now from minus 1 to 1, from minus 1 to 1, only this signal is existing, okay, obviously this value is going to be 1. Right, yeah. So from minus 1 to 1, only this single signal is existing with the value 1. So in the equivalent signal also, from minus 1 to 1, the equivalent value is going to be 1. So we are going to have value of the signal as 1 from minus 1 to 1. Now from t is equal to 1 onwards, both the signals are existing with each value 1. So when I add these two signals, value of the equivalent signal is going to be addition of these values. So from t is equal to 1 onwards, the value of this equivalent signal is going to be 1 plus 1, which is 2. So this is going to be a step change of 2. Step change of 1 and a total value of 1. So what do we say is, there is a step change of 1 at t is equal to 1. There is a step change of 1 at t is equal to 1, right. So this is what I am saying, that whenever you are required to express a signal which consists of only steps, you can just express it as shifted step signal. Now see, a step began at t is equal to minus 1. So to represent this step change at t is equal to minus 1, I wrote this as u of t. Okay, I am writing it again. a step at t is equal to minus 1. So I wrote this as ut plus 1. Since step change means change in value. Initially value was 0, finally value became 1. So this is the step change, this is a step change of 1 unit. So this is what the coefficient is going to be, 1 ut plus 1. Now this value continued till t is equal to 1. So we are not required to write anything. Now again there is a step change because the value changed from 1 to 2, which means a step of 1, step change of 1. Now what do I do? The coefficient is going to be 1, and where did I get this change? At t is equal to 1. So what do I write it as? U of t minus 1, shifted step signal, right? So this is how we are representing a signal which consists of only step as coefficients, as sum of shifted step signals. Now suppose you've got a signal like this. We're going to come back at this after looking at these basic signals first. So next, suppose you've got a signal like this. So this or here also you can see that it consists of 2 steps only. First step is this, which lies at minus 1, and then we again having a step at t is equal to 1. So this signal consists of only steps. If a signal consists of only steps, we can represent it as shifted step signals, sum of shifted step signals. So first step that I got is at minus 1. And what is the length of the step? Value of the step 1, because initially the value was 0, finally the value became 1. So what I can write it as 1 into u of t minus minus 1, because the step occurred at minus 1, so I am writing it as t minus minus 1. Now the value continued, value is continued. Now again at t is equal to 1, I am having a step change, but now this is not a positive step change, this is a negative step change. Why? Because initial value was 1 and finally became 0. So this is going to be a negative step, this is going to be a negative step of minus 1. So what do I write it as? Coefficient of minus 1, and since the step occurred at t is equal to 1, ut minus 1. So this ft is actually ut plus 1 minus u of t minus 1. From here also you can see, if I am just subtracting this signal from this one, what happens is all the values of this signal after t is equal to 1 get subtracted. So I am left with only values between minus 1 and 1, which is this signal itself. So any signal which consists of step can be represented as sum of shifted step signals. Now we are going to look at this signal. So basically what we are looking at is where does the step occur and what is the magnitude of the step. We just look at the size of the step, magnitude of the step, which is going to be the coefficient of step signal, and the instance where the step occurs, which is going to be the shift of the step signal. So now the first step here in this signal occurs at t is equal to minus 3 and the value of the step is going to be 2. So I start writing this ft. First step occurred at t is equal to minus 3 and of size 2. So I am going to write it as 2u t plus 3. Okay, t minus minus 3, which becomes t plus 3. Now this value continued till minus 2. At minus 2 I had a fall. I had a fall of 3 units. See, from 2 I came to minus 1, which is a total fall of minus 3. Since I have decreased the value, the coefficient is going to be negative. So this is a fall of minus 3. So I write it as minus 3 u of t. At what instant this step has occurred? Minus 2, which means t plus 2. Now this value continued till 1. Right, this value continued till this instance. So there is not going to be any value in between, nothing is going to come in between. Now at 1 I again jumped, okay, I jumped 3 units. This is a positive step of 3 units. So what do I do? Plus 3, and at what instance? T is equal to 1. So t minus 1. Okay, so this is going to be t minus 1. Now this value is continuing till t is equal to 2. At t is equal to 2, I had a negative step of 4 units. From 2, my value changed to minus 2. See, I am just calculating the coefficient by final value minus initial value. Minus 2, which makes minus 4. So this is going to be a negative step of minus 4. At what instance? T is equal to 2. So t minus 2. Now the same value continued till 5. Now at 5 what happened? I had at this signal, the final value of the signal became 0. Okay, so I had a positive step of how much? 2 units. Why? Because initially the value was -2, finally it became 0. So 0 minus -2, which makes it +2. So I am going to write it as +2, and at what instant? T minus 5. Okay, so this is going to be my complete signal. Now there is one way to verify whether you have represented the signal correctly or not. You can just note it also. If a signal is having finite duration means see, here you can note that the signal is lying only between t is equal to -3 to t is equal to 5. Okay, if this line was not there, suppose this was not there, the signal would continue till infinity. Duration of the signal would not have been known. But here you can see that the signal lies between t is equal to -3 and t is equal to 5. The signal is of finite duration. So whenever you are having a signal of finite duration, if you just add these coefficients, if you just add all these coefficients, their sum is going to be 0. Just check, just add 2 minus 3 minus 1 plus 3 plus 2 minus 4 minus 2 plus 2 0. So what we can note here is, for a signal of finite duration, sum of coefficients of shifted step signals is going to be 0. This is always going to be 0. Okay, if the signal is of finite duration, sum of coefficients of these shifted step signals must be 0. So in case you have got a wrong representation, in case you forgot to include any step, you can just add and confirm that if the sum is 0. Okay, right. Now as we have looked at unit step signal, as we have seen that any signal made of only steps can be represented using unit step signals, basing unit step signal only. Similar to this, any signal which is made of straight lines only, which is having only straight lines in its representation, can be represented using unit ramp signals. How? See, when we looked at definition of unit ramp signal, we saw that coefficient of this unit ramp signal represents the slope of the line, right? We studied a property something like this. Like this, I guess. So what I mean is that this coefficient of the signal is going to represent the slope of the line, slope of the slope of the ramp. So we are just using this property. If a signal is just made of lines, straight lines, so then the coefficient of the signal is going to represent the slope of the line, and the shift in the signal is going to represent the instance of shift. For example, suppose you've got a signal like this. Now as you can see that this signal contains of lines only, okay, this is consisting of straight lines only. So according to our definition, what we can do is we can just represent this signal using shifted ramp signals only. Now how are we going to do this? See, first ramp is occurring at -2, first straight line, first change in slope. See, slope of the line before this point, was this was x-axis, so slope of the line before this point was 0. Okay, there was no change in y, so slope of the line before this point was 0. After this point there was a change in slope. What is the slope of the line? How do you calculate slope anyways? Slope is change in value, that is basically change in y upon change in time, which is basically change in x-axis. So if I just want to calculate slope of this line, what it is going to be, final value of the signal is 8, so 8, initial value was 0, minus 0 upon, finally time has become 0 minus, initially time was -2. So this is going to be 8 by 2, which is 4. So slope of this line is 4. So initially slope was 0, now the slope changed and became 4. So how can I just represent this line? As I have already told you, we are going to take slope as coefficient of the signal and point of change, instance at which it changed, minus 2. So I can write it as 4t plus 2, right? Now the next change in slope that we look at is, okay, first we are going to find the slope of this line also. So final value here was 0, initially value was 8, 0 minus 8, finally time was 2 and initially time was 0. So this gives us minus 4. Now see, next change in slope which is occurring is at this point at t is equal to 0. Slope changed from 4 to minus 4. So change in slope is going to be minus 8. Change in slope was minus 8. Okay, because finally slope became minus 4, initially it was 4, which occurred at t is equal to 0. So change in slope was minus 8 and it occurred at t is equal to 0. So we are going to write it as minus 8, coefficient is going to be minus 8, which represents change in slope, and this is RT minus 0 or RT is equivalent, which represents instant at which slope changed. Now the next slope change occurs at t is equal to 2. Here the next slope change occurs, which is from minus 4 to 0, okay, minus 4 to 0. So I am going to write it as, okay, so change in slope is of 4 units, right? Initially the slope was 4, now it became 0. So change in slope is 0 minus minus 4, which is plus 4 at r t minus 2, because this is the instant where the slope change occurred. So this is how we are representing any signal which is made up of straight lines only with the help of shifted ramp signals. Coefficient of the signal is going to represent change in slope. It is not going to represent slope of the line, okay. Generally children are making this mistake that the coefficient they are representing slope of the line. See, here you can represent slope of the line. Now what are you going to give the coefficient that r is equal to 0, t is equal to 0 then, right? So this coefficient is representing change in slope, always change in slope, and shift in the signal is representing instance where the slope changes. Now if we are having some signal, okay, one more thing that you can note here is, here the sum of coefficient is not representing anything, okay. In case of unit ramp signal, this is, although this sum of coefficient is 0 here also, and this is a finite duration signal, but this is necessary is not going to apply to every signal. So here sum of coefficient is not representing anything. So now we are going to look at a composite signal which is going to contain of straight lines as well as steps, okay. We are going to look at a simple signal, trapezoidal pulse, and we are going to look how we are going to represent it using ramp as well as unit step signals.